What is Ethereum 2.0? Ethereum's consensus layer. Ethereum is an open-source, public blockchain-based distributed computing platform with smart contract functionality. It provides a decentralized option for applications to be deployed on top of its network without the need for intermediaries. Ethereum enables developers to write and deploy decentralized blockchain apps. To make more use of this technology, the Ethereum development team released a new version called Ethereum 2.0, which was integrated into Geth 1.8 at the end of October 2017. Ethereum is a world-leading blockchain platform for smart contracts. It has huge potential, which is yet to be fully unlocked. Currently, the vast majority of transactions on Ethereum are cost-prohibitive due to high gas prices and slow transaction times. Ethereum, ETH, the world's second most widely used blockchain platform after Bitcoin, BTC, aspires to be all its forerunner is not yet falling short of doing. Ethereum is being held back by some of Bitcoin's constraints, such as Bitcoin's insistence on a proof-of-work (POW) consensus mechanism and Bitcoin's overall lack of scalability. These limits are preventing Ethereum from becoming more popular. The goal of Ethereum's multi-phased upgrade, which includes the beacon chain, the merge chain, and the shard chain, is to increase the scalability and security of the Ethereum network by making multiple adjustments to the underlying infrastructure. The transition from a consensus approach known as proof-of-work (POW) to a model known as proof-of-stake (POS), which both offer variable degrees of divergence from one another in the protocol, is the most noticeable change. In 2013, Vitalik Buterin, the architect of Ethereum, presented a blockchain platform that supported applications and other benefits that were not necessarily centered upon financial transactions. Buterin envisioned a future in which developers could leverage the power of decentralized to build governance systems, lending systems, databases, and more. They would also be able to represent tangible assets in a digital space. Buterin believes that Ethereum is a global supercomputer, despite the network having trouble validating more than a few hundred transactions in a reasonable amount of time. Users that transact modest sums on Ethereum must pay fees and additional costs that can often exceed 100% of the transaction amount. Ethereum is founded on some dubious technology, which is surprising given that it is a platform to revolutionize how people communicate with one another across a network. Thankfully, Buterin, several network developers, and the Ethereum Foundation are all aware of the project's constraints. Additionally, the Ethereum development team is aware that the constraints of Ethereum's blockchain make it difficult for institutional investors and other parties interested in embracing Ethereum. Buterin and the ETH crew have described a network upgrade that they term Ethereum 2.0, also known as Eth2, to address the scalability issues that Ethereum is experiencing. Improvements to Ethereum's core functionality are included in the upcoming Ethereum 2.0 release, however, implementing these changes will take years. Since the year 2020, developers working on Ethereum have been putting in many hours to bring about the network's update in the hopes of making Ethereum far quicker, more secure, and more accessible than it has ever been. What is Ethereum 2.0? The Ethereum 2.0 consensus algorithm is a considerable departure from the previous version. The Eth2 upgrade, referred to as the consensus layer upgrade, will result in Ethereum converting to a proof-of-stake algorithm. Previously, Ethereum used an algorithm that required a significant amount of energy to validate transactions. Compared to a POW method, a POS1 offers several advantages, including the capacity to change many network characteristics, such as its scalability, security, and accessibility. An upgrade to the Ethereum blockchain, Ethereum 2.0, also known as Eth2 or Serenity, also goes by these names. The upgrade will improve the speed, efficiency, and sustainability of the Ethereum network, allowing it to avoid bottlenecks and handle a greater number of transactions simultaneously. However, Ethereum 2.0 does not exist either, as the Ethereum Foundation said in January 2022 that it would stop referring to the upgrade as Ethereum 2.0 in the future. The rebranding is meant to reflect that what is taking place is an upgrade to the existing network rather than the creation of an entirely new network. Consequently, Eth1 is now known as the execution layer, which is the location of smart contracts and network rules. On the other hand, Eth2 is known as the consensus layer, which guarantees that devices contributing to the network behave by the rules of the network. What is the Ethereum consensus layer? The consensus layer is an integral part of the Ethereum 2.0 update that is essential to the entire operation of Ethereum. It includes a network rule system and validates the network's transaction history. The mechanism for consensus upgrades is a two-step process, with two separate upgrades that together make up Ethereum 2.0. Sharding and various other changes will be implemented in 2018 in what's known as Step 1 or Layer 1. This upgrade implements a new data structure known as shards. The Ethereum Foundation has emphasized the importance of a sharding upgrade. In 2017, the ETH team informed the community that it was high time for Ethereum to implement a new system that would enable blockchain nodes to be divided into separate pieces. This is to use the network's enormous computing power, which is only usable if shared with other users who can contribute their processing power. Ethereum Consensus Layer Basic Concepts. Proof of Stake. The Ethereum 2.0 consensus algorithm is a considerable departure from the previous version. The Eth2 upgrade, referred to as the consensus layer upgrade, will result in Ethereum converting to a proof-of-stake algorithm. Previously, Ethereum used an algorithm that required a significant amount of energy to validate transactions. When compared to a POW method, a POS1 offers many advantages, including the capacity to change many characteristics of a network, such as its scalability and security. The Ethereum 2.0 upgrade will also offer several other enhancements, such as new and improved forms of Casper, namely Casper the Friendly Finality Gadget or FFG. This version of Casper is reportedly more scalable, has a larger capacity to handle transactions, and is less computationally expensive. The Ethereum 2.0 upgrade will also feature a change known as sharding, designed to divide the network into various pieces that can work together simultaneously. The Beacon Chain. The move from proof-of-work to proof-of-stake was initiated with the launch of the Beacon Chain, which occurred during Phase 0 of the network upgrade. In the beginning, the Beacon Chain was in charge of managing the registry of validators. After the merging with the execution layer is completed, however, it will be the Beacon Chain's job to ensure the safety of the whole Ethereum network. When shard chains are finally implemented, it will be the responsibility of the Beacon Chain to synchronize the data across all of the chains. Putting Ether on the Beacon Chain. Every Ether that was put into the Beacon Chain in Phase 0 came from a transaction that went to the deposit contract in just one direction. It is necessary to deposit 32 ETH to set up a validator. Please be aware that ETH will not be available for withdrawal until many later phases. Shard chains. Within Ethereum, shard chains are often referred to as parallel blockchains. Because the network is partitioned into shard chains, it is now possible to process more transactions in parallel, contributing to increased speed and scalability. Upgrading Ethereum from a single-lane road to a freeway composed of several lanes is accomplished by adding another lane through the use of shard chains, the organization that manages Ethereum. Staking. In a blockchain that uses a POS consensus method, staking refers to the action of a node that contributes data. To add blocks to the blockchain and confirm those blocks, an individual is required to stake a particular quantity of network tokens. Validators are the ones responsible for carrying out the staking process on Ethereum. On Ethereum, the minimum required amount of Ethereum to participate as a validator is 32 ETH. If validators participate in the network honestly and contribute and verify blocks, they will see an increase in the value of their network stake. A validator risks having their stake reduced if they engage in behaviors considered harmful or disconnected from the network for an extended period. Staking rewards. When a validator responds to a request from the blockchain promptly and provides accurate proposals and attestations, they are paid with Ether. Inclusion distance refers to the amount of time it takes a validator to finish and sign a responsibility, and it serves as the basis for these benefits. For a validator to be eligible for the full reward amount, the entire process of signing must be completed inside a slot of time that lasts 12 seconds. If the latency is greater than 12 seconds, interest earnings will be lower, and there is a chance that the slot will be missed entirely, meaning there will be no reward. Validators can obtain rewards for blowing the whistle on unethical behavior by bringing it to the community's attention. According to the most recent projections, the yearly percentage payout for ETH2 validators will range between 15 and 18% during the first year of staking and between 8 and 10% the following year. Staking penalties. A validator's staked ETH will be reduced, albeit only slightly if disconnected from the network for an extended period. However, a validator's staked ETH will be reduced significantly if they engage in malicious behavior, which may eventually result in the validators being slashed and removed from the network. Slashing. Suppose a validator on the Ethereum network engages in malicious activity. In that case, that validator will lose a sizable percentage of the ETH that they have staked, up to the entirety of their 32 ETH stake, and they also stand to be removed from the network. Slashing protection is an essential component of validator client software for DIY stackers, as well as the product offering of a staking service, because it protects against the possibility of a validator unintentionally engaging in a slashable offense and putting their ETH at risk. Leakage from inactivity. If more than 1/3 of validators are offline at the same time, the balances of the offline validators will continue to drop over time. At some point in the future, the balances of the offline validators will get so low that they will be removed from the network. This will ensure that the online validators can proceed with the process of finishing the chain. Validator. On Ethereum, validators confirm transactions before new blocks can be proposed. Validators are also responsible for creating new blocks. One must stake 32 ETH to become a validator, and this amount is subject to growth or shrinkage, depending on how well the validator carries out the responsibilities it has been given. Compared to the concept of a miner on the legacy Ethereum chain, a validator is distinct in that validators are solicited by the POS protocol to propose and validate emerging blocks. In contrast, miners on the legacy Ethereum chain compete with one another to generate new blocks using the POW method. Conclusion. The POS model is a consensus mechanism for public blockchains and is one of the 3 most commonly used methods. Once implemented correctly, POS can truly contribute to an exponential increase in the speed and scalability of a blockchain while also lowering costs. On Ethereum's current development path, the new POS model could very well be Ethereum's saving grace as they move forward with their implementation.